big dog.
What up, everybody? Y'all saw the poll. It's over. Welcome to Coffee Hour. It is Thursday, the 31st, the last day of the month of July. Thanks for taking the time out of your day to join me here on Coffee Hour. We're going to unpack a lot of stuff today. We're going to talk standby systems a little bit because, again, with hurricane season and all the stuff and everybody all over the country using portable generators, we're going to talk a little bit about that today. Standby power, generators, an upcoming video that I'm doing, all that type of stuff. As always, I live vicariously through you folks. I appreciate the emails and the texts that I get. I try to communicate with all of them the best I can in the timely manner. But at the end of the day, again, I appreciate all of them. Do me a favor, in the comments, no matter what platform you're on, let me know who you are, where you're from, what you got going on. Maybe you're taking a test soon or something like that, and you need a little encouragement, or maybe you have a question. We will most certainly do my best to address it. Today's episode is sponsored by Fast Tracks Tube, which is our exclusive video platform. Check it out. A lot of videos over there and that type of thing. So again, always excited to have everybody give us comments on Fast Tracks Tube, how you like it. There's a lot of stuff to unpack on that sucker. I mean, it is you won't use all the features, okay? And in fact, I don't even use hardly all the features on it, but it's there. Things you can save and bookmark and do all kinds of weird stuff. So make sure you check it out. Again, my name is Paul Abernathy. If you don't know who I'm from or where I'm from, I am in Virginia. We are Electrical Code Academy. It's a corporation located in Mineral, believe it or not, Mineral, Virginia. I moved and left Texas. I'd been there for 11 years. I serve as the Director of Technical Services for Encore Wire and Prismium Corporation. I still do. And make sure I turn the audio off for here on TikTok. For those that aren't familiar, we do stream behind the scenes over on TikTok. So if you want to see behind the scenes and see the fat guy and the mixing boards, that's about all you'll see. Please feel free to do that. Again, it's Master the NEC on all of our social platforms. Okay. If you're looking for an exam prep course or you want to learn the NEC better, obviously fasttracksystem.com is the way to go. And if you're a master electrician and you want to raise your game to the next level, then you can become a CMECP. The hat's crooked. Okay? You can become a CMECP and raise your game to the next level. That type of scenario. All right. Enough of that out of the way. We'll do some shout outs to everybody, but we're going to talk briefly today. I'm going to try to stick to the hour. I keep saying I'm going to do that. I understand I got to be good stewards of your folks' time, so I'm going to do my best. But one thing I wanted to talk about is, if you remember the other day, David, who's in the house here, was submitted some tech comments, and I couldn't really gather them because they were all broken down, but he sent me an email. David, you sent me out, and I concur with your email, David. But what David was talking about is, we in previous episodes, when we're talking about calculations, and I talk about houses, and I talk about using the optional and standby method, you have to, optional and standard method. I'm locked into standby today, folks. I don't know why. I explained that you can use how you would use 220.82 and how you would use everything. So I explain it out, but we really didn't talk about remote distribution panels and how they're calculated out. So the ability to use the optional method, that's for a dwelling unit, okay? And it states right in it for the dwelling unit, which implies that it's doing the entire dwelling unit. This could be applicable, for example, if you're in a multifamily building. There's obviously, if you're 3 or more, you're going to use a different optional method. But this, for the individual dwelling units, that's for the full load service. For the individual dwelling unit, you most certainly can use the optional method calculation in part 4 if you're doing that dwelling unit and everything's enclosed in that dwelling unit. The optional method was not designed for you to be able to take a large dwelling, for example, and do all these remote distribution panels and use the optional method for every feeder that's going out to every individual sub panel, if you will, in this dwelling. That was not the design. So you would typically use the standard method. So it's a great point, and I couldn't read it all because the way it was broken down. So, but there's a subtle point here. The subtle point is there are a lot of times educators out there in the country that'll say you don't need to learn the standard method or the part 3 method. And they're very famously putting it out there that as long as you know how to do the optional, you never have to worry. Well, I think a little subtle thing that David is kind of a hit on, and I got to make sure I cover all these things. That's why we love coffee hour, so we can have these discussions and learn. I think one of the subtle points is that the remote distribution panels that you're feeding sub panels aren't supplying if it's not supplying a dwelling unit, then it's irrelevant. You're going to use a standard, and we talked about that. But you can't just hit any of these little remote panels in a big house and think that you can use the optional method for that. And the reason for that is lack of diversity. So at the service, you could use the optional method, but when it comes to the individual sub panels, again, not dwelling units, they're sub panels, then the problem with that is you don't have the same level of diversity. So if you're using the part 3 method, which is the normal method, so we kind of got to I have to train myself from saying standard method versus optional. I got to train myself into saying it's part 3, it's the regular load calculations versus an optional, not standard. I guess it means the same thing, but for me, I got to remember that the regular calculation is going to apply in many, many applications. You only get to use an optional method when it's specifically applicable. And so because it states in 220.82 a dwelling unit, and it talks about a single and all this kind of stuff, that it's not talking about being able to use that. Now, also in context, because it was great topic for today, talking about standby power, when I'm sizing a generator, I usually always just think of whole house generators, because that's really where you do a calculation, right? When you're just going to run everything in the house. And whether you're shedding anything off or not, I don't usually worry about that. I take all loads that could plausibly be on. The shedding is just going to help the generator, but as far as calculating, I try to calculate everything out, and then I'll work backwards to any type of built-in shedding or something like that when I'm doing my calc. But the question is, can I use a standard or optional, the regular method in part 3 or the optional method in part 4 for a generator? And if it's a whole house generator and it's running everything, then I would say you can use the optional method for that as well. If it's running everything, it's supplying the dwelling. But when it comes to like the standbys where you're doing manual transfer with an interlock kit and things like that, you're selecting loads. And then you're not really, in this scenario, you're not really sizing anything in a sense that you're just taking, okay, what is the capacity of this generator? Right? If it's a 50 amp, if it can have a 50 amp output, then you size the cables to that, the inlet's 50, the breaker's 50, because you know that you're selecting the loads, and you have to go through and realize that the limiting factor is the receptacle and the generator's watt capacity. Okay, there's a start and run. So there's really no big calculation for that when you put an inlet in. Okay, you're just going to have to manually select the loads. Now, if it's an automatic transfer, then it's acting just like the utility, and it will switch. Okay, and there's little nuances in there, but I most certainly think that there is an application where you can use the optional method depending on what you're switching with that generator. Okay, if you size that full generator and you don't need load shedding or you don't have any of that stuff, then you basically size it, and nothing says I can't use the optional method. There's nothing in the code that says I can't. But we have to be careful in the fact of understanding that if you're going to have a remote distribution panel in your basement, and you're calculating the loads for that application, then you're not going to be using the optional method. You're just going to be using the regular standard type of calculation in part 3 for that panel. Now, could that ever, in a weird scenario, in a weird world, could that ever mean that the feeder to that remote distribution panel could be larger than the service application based on a calculation? It may be a weird situation where it may be. But remember, if you're using, for example, a situation where you can apply the 310.12 for the service, you may have a feeder that's going out to a remote distribution panel, that may ultimately be larger than what would be the service connectors coming in, okay? And the code people say, well, doesn't it say in 312.5 that it never needs to be, that the application meant that the feeder doesn't have to be larger than the service? Yes, that's when you're doing a true feeder that supplies the entire dwelling. That's the whole premise of 310.12. Not when we're just going to a remote distribution panel that's got a certain number of loads. I know a big house, for example, that this wasn't the case with the service, but it had one remote distribution panel that had the majority of the loads, but not all the loads, but the majority of the loads. Sub-zeros, things like that, you know. And then they had a separate remote distribution panel that handled other various loads. Well, I could not use the optional method of those panels. One is because that feeder wasn't supplying a dwelling unit, and it did not handle 100% of the load, so I couldn't use 310.12 for any of that. So I just had to use a regular load calculation to do that. And again, usually when you get to that level of a dwelling or a building, at the end of the day, the service is going to be much larger anyway, even if you did have a situation where you could use the 83% rule, right? But again, just wanted to make it clear, and that's what David was talking about. And David, I concur 100% with your assessment. And that's why it's so important, folks, to send stuff in to paulabernathy.com, because it gives us an opportunity to look at it and read it and try to have a communication about it. But I 100% agree. Before I get into today's lesson, we're going to talk about just standby power systems, kind of keep it residential. And we're going to promote a book. I don't write the book. This edition, I did not write the book. Last edition, I was co-author. This edition, 2023, I did not write the residential book from Cengage. And we don't offer that course anymore. But we do lessons out of it and encourage you to get that book. If you, for example, are really wanting to hone in on residential stuff, then there is a publication. We'll show that here shortly. All right, let me do some shout outs real quick before we get too deep into this. What's up, Adam? I am doing good, my friend. Glad to have you here. Paul, welcome. My printer down there in Houston. Glad to have you here. Here's David in the house from down in Southwest Florida. Hopefully the weather's nice down there. It's going to be rainy today here in Virginia. Speaking of Virginia, here's my neighbor up in Richmond, Virginia, Haas. Thanks for joining us, Haas. Glad to have you here. Michael's in the house. Michael says, good morning. Yesterday's discussion, Leviton does make a 20 amp lever action. That's the new ones. So that's the new ones with the, is that the ones with the spring, the Wago style back ends? Yeah, they probably do make it. That's probably their newer ones. And I think they're cool. You know, everybody I'm like, people hating on the Wagos and Wago style. I like the lever action versus the push in. In fact, I used two of them yesterday, the lever action ones, okay? That type of thing. So in some little project that I was doing yesterday, and I have no problem with it at all. I will not lose an ounce of sleep over those connections. I think they'll be fine. What's up, Tom? Glad to have you here, my friend. Are you still up in BWI working? What's up, Jonathan? Again, thanks for the email, Jonathan. I appreciate it. Family's doing good, and I appreciate your loyalty to the program and to the products. Keep at it. Keep focusing on your studies. You're gonna get there. Keep taking your time, and you're gonna nail everything. You got plenty of time. What's up, Tara? Glad to have you here. Joe Wheeler Lake, very famous lake for fishing. Let's go. I'm out that way. I'll holla. I have not put the boat on the lake yet since we got it back. I assume it starts, but I have not done it. Let's see. Adam says the tube is the bomb. Yep, and we're expanding it, and we have some other things that we're working on it. But yes, the tube is the place to be. Absolutely. What's up, Melting Toast? Rob, I am having a good day, my friend. Thank you very much. Appreciate you here. We got some big dog.
Woo, 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 woo. Big dog.
What is up, Poppy? Glad to have you here. Good morning, Terrence, from up in DC, Maryland, Virginia. Contractor up there. Red Dog's in the house.
Woo, 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 woo.
Buenos
Big
dias,
dog.
Big dog. Let's go. Santana, good morning. Glad to have you here. Got my coffee too. Doing a little donut blend today. Not doing the Dunkin' Donut today. A little donut blend. Let's see, what do we got going on here? Good morning, Robert from San Antonio. Glad to have you here. Titan, Mr. Simplex is in the house. James, thank you. Good morning. Glad to have you here. Let's see, Manny, Wyoming, up in the wooded area or mountainous area. What the hell? Wyoming, isn't it just big, wide open place? But I bet, bet it's awesome. I love that type of out in the country type of thing, out in the wherever. I think of Wyoming as just like out where there's roaming wild animals and stuff. Maybe I'm wrong. What's up, Ryan? Good to have you here, my friend. Let's see. Stramina, I think you have humming music running in the background and it's making it hard to hear you. Humming music? Are you talking about the fan? You can actually hear that? Oh, actually, you know what? It does seem like it's coming in the background, doesn't it? All right, hold on for a second. Is it really? Wow, that's louder than I thought it would be. Oh. I did not think that would come through. I think I know why, though. Because I have adjusted my settings on my microphones. And I have adjusted the mic up to the point where it is probably pulling in a lot of extra stuff. So I will make sure I have that set up a little different. I don't know how to do that, but anyway, I don't know why that audio is pulling in like that. Let's see. I don't think. Let's see. Let me see. Let's see my audio. If my audio allows me background noise reduction, that might work a little bit better. Let's see here. I don't know if it does work better. I don't know. You'll have to let me know. Sorry. Is what it is, my friends. But I do see there's something in the background. Hold on. Interesting. I don't know. Oh, I know what's going on. Sorry about that. How's that? That better? Yeah, I just did an update. Sorry about that. Let me go back to where I was at. Hopefully you all heard me enough through the background. I had, hold on. I know what it is. Hold on. There we go. What is that? I don't even know what that sound is. Anyway, I had the wrong settings on the microphone. My bad. All right, hopefully y'all hear me now. My bad. It's a Thursday. I'm bound to screw something up, but if you can barely hear me. And now everybody should be able to hear me okay. Is that background music? I don't even know what it said. Pulsating background noise. Sorry. I should have noticed it. I thought it was something. I was like, what is that? But sorry about that. It's always the morning shows, right? 21 minutes into it, and I'm just now hearing about it because I didn't look. Are you brainwashed by the frequency I'm hearing? Good morning, everybody. Rob, good morning. Glad to have you here. Good morning, Eddie. Glad to have you here, my friend. Good morning, Angel. Glad to have you here. Hopefully y'all heard anything. Joseph got poison ivy. Ugh, that's not good. Glad to have you here. Let's see here. David, good. I don't know. So ask me, could y'all hear everything I said at the intro, even though I had the background music? So I don't have to go over all that again. Y'all did at least hear what I said, right? Did it at least come through? Please, somebody tell me at least you heard what I was talking about, okay? So, good morning. Thank you, Angel. Glad to have you here. I got music in the background. Yep. Good morning, Adrian. Good morning. Glad to have you here. Electrician says he likes it. It's massaging his brain. Sounds like background music. Did it? Sounds like Alien versus Predator. There, it's gone. Yep, that was it. Perfect. Yeah, no, actually it wasn't the sound. I had pushed something accidentally on my soundboard, and it constantly runs. And I forgot that it was on, and I just now noticed over there, I saw the thing bouncing up and down, and that's when I realized that that was a feature that I had playing in the background. Okay, as long as you could hear me. All right, good deal. Just you know, I forgot I pushed the wrong button, but I don't want to make sure I don't have to repeat everything I talked about earlier because people couldn't hear me. Anyway, okay. I don't want background music. I just want me. Let's see. All right, let's see here. The music was faint. Okay, good. Good. All right, good deal. All right, let's see. Good morning, Steven. Is it Stephen, good morning. It was hypnotical music. All right, so. All right, anyway, if I missed any of you because I got distracted, again, remember I have a worst case of attention deficit disorder you'll ever find in somebody. Undiagnosed as a child, but that's okay. All right, so what we're going to do here today is we're just going to look at some stuff, stand by, and I do want to promote a book. It's not my book. Last cycle, I helped co-author it. 2023, I did not. I guess they didn't want my involvement, and that's perfectly okay. And it won't like I didn't have enough things on my plate. It will. But anyway, let's go look at it. So this is what we're talking about. So this is the book. It's Electrical Wiring Residential. And we used to have a course based on it. It sounds like I had a rave party going on. Dude, I party hard. Okay. We got the party going on up in here. So this is a book. If you're into residential, I highly recommend this book. It's from Cengage. It's residential. It breaks it down. We use it for lessons and talking different lessons in it. But it's a really good publication. So, and we're obviously going to be working, looking at stuff out of chapter 32 today. And we'll go to the book if we need to. We'll go to the lesson if necessary. So a couple of things that we'll be tackling today, hopefully, is it will be explain some of the safety concerns on optional standby systems. With that said, I do have a video that's going to be coming out in the next week or so, and it's a real simple, down and dirty video. I'm not into those lessons when it comes to. I'm not into those, stuff where show you pulling stuff through studs and making up boxes. Okay, that type of thing. Okay, I'm just not into that. But I did want to do a video that shows you how to take a bonded generator and make it an unbonded generator per the manufacturer's instructions, mind you, it's important. And so that it can be used in a house setup, so it can be plugged into an inlet in a dwelling. So I do want to show you that. By no means am I trying to tell anybody how to take a bonded generator and make it unbonded. That's your responsibility. That's your research. That's you do you. Just understand putting certain things on systems. You have to make sure and check with the manufacturer and how you use equipment. You definitely don't want to put a bonded generator, which is typically a portable generator, which you do want to be bonded if you're using it out in the field, so that your GFCIs on the actual generator work fine. But if you're going to use it for not a whole house, but if you're going to use it for a house application and plug it directly in with an inlet, for example, in an interlock kit, and you're not going to be putting a transfer switch in, just going to be, a full, that switch is a neutral, by the way, then you're basically going to, if you're not switching, you could put a transfer switch in and you still wouldn't switch to neutral. So again, it's important we know the difference. So most generators, if you're going to use it on a dwelling, then you don't want an improper case to neutral. So when you buy a portable generator and you use it on a job site, all right, well, the way that functions, it's going to be bonded generator unless it states otherwise, okay? Well, we don't want to use a bonded generator if we're going to hook it into a whole house or a house application, okay? So I'm doing a video on that, and I'll break it down, and I'm just going to use one particular model, but a lot of generators have manuals that explain how to do this, especially any of the ones that are larger, that are designed to be used in a backup, standby setup on a house, for example. They'll have instructions how to do it. The smaller little ones, job site ones, real small, 3,500 watt and less type of things, you got to reach out to the manufacturers, which those I would not recommend anybody just trying to do anything with that. always contact the manufacturer, that type of thing. Okay. So anyway, I'm going to do a video on that to explain all those nuances in that. So anyway, we're going to talk a little bit about standby power. If you have any questions, please. David, you taught for IEC. That's awesome. That book originally, Ray Mullins and then Phil Simmons took it over. And then I helped in the 2020 edition. And then in the 2023, they kicked Paul to the side. And Phil says he didn't want to work with me anymore. I'm too hard to work with. I can buy that. I can believe that. I probably am a little bit hard to work with. Explain the basics of standby power and summarize the types of standby power. Interpret the wiring diagrams for portable and standby power. Explain transfer switches, disconnects, and sizing recommendations. Summarize the National Electrical Code, requirements for standby power, and all that kind of thing. Y'all all know, right, that for residential, there is never a case where it's going to be emergency. It's always going to be optional standby. So you're always going to be working out of, as far as the code's concerned, you're always going to be working out of 702 when it comes to that, right? Now you're going to be dabbling into other areas, okay, interconnected systems and things, but for the most part, that's where you're going to be working out of, okay? So let's see here. Let me go on and get the code up here, just so I can make sure. So for you folks, you're probably going to be, again, working most of the time when you're talking about generators, you're going to be in 445, right? So you can talk 445 for generators, but when you're doing optional standby, you're going to be in 702. Right? You know, y'all know there's three different types of standby powers, right? There's emergency, there is legally required, that's 701, emergency 700 of the NEC, and then 702 is optional standby. So 100% of the time in a residential application, even if it's supplying a receptacle on the second floor to your mother-in-law's life support system, it's still not emergency. Okay, it is still optional power. Okay, which means you're not required to have it. Right. Now I can see, and then of course you're also going to deal with 705 as well, which is basically interconnected electric power production sources. So you might have to deal with that. And but for the most part, we're going to be in 702 for optional standby systems. Okay, that's where we're typically going to be. All right. Okay. Let's get over into look at what we got going on. Okay, introduction. Generators can be connected to the electrical system of a residence in one or two ways with four different configurations. Permanent generators, Generacs, Kohler, all those type of things are permanent, okay? And then you got to deal with whether the neutral is or is not switched by the transfer switch. This is very important. Same with the portable generator. You'll deal with whether the neutral is or is not connected, okay, to the frame, right? All of these things you have to be extremely aware of when you're using a generator. I tell you right now, and a lot of it, if you don't unbond the generator and you connect it to a whole house, it will trip out the GFCI. If there's a GFCI on the 50 amp breaker portion, it'll trip it out. So again, you'll in all kinds of things you'll run into. But the one thing we don't want to do is take a generator that is bonded to the frame, so the neutral's bonded to the frame, and put it on a house, and then what happens is you're not switching a neutral, so you end up getting circulating neutrals coming in, going back, going in, and even when the generator's not running, it's going to go out to the generator. It creates a hazard, okay? So at the end of the day, because that neutral isn't switched, so it's all constantly in, so it's going to go out through the neutral, going to go over to the frame. If it's not unbonded, it comes back from the frame onto the equipment ground, back onto the cabinet. So you do have other paths for current to flow, and that's not a good thing, right, in that scenario. So that's why we want to break that at the generator if it is not separately derived. Now, y'all all know the term separately derived. Transformers, other than the auto transformer, which is just one winding that's tapped, that is not a separately derived system. But all transformers are separately derived except for an auto transformer. Now, a transformer is a primary and secondary. They don't make intimate contact, although they may be connected together through the bonding and grounding. It's still a separately derived system. There's two separate systems. There's primary, secondary. They're very close in windings, but they are not intimate together, connected. Generator, we think of the same concept when we say separately derived system, is that can we take that generator and totally isolate it away from the utility coming in, okay? And totally isolate it away. And the only way you can do that is through for a generator, only way you can do that through a transfer switch is to switch the neutral. If you don't switch the neutral, then it doesn't meet the definition of a separately derived system as defined in the National Electrical Code, right? So it creates a problem. And so when you do put one on it, now you run the risk of making it a hazard for your customer. Now, it may work, may not have an issue until it becomes an issue. And then, of course, you're going to be held liable because you should know better, right? So if the rule of thumb, if you're just going to use a portable generator, you're doing job site generators, you need that connection to the frame, okay? To make sure that your GFCI is going to function properly on the device that's mounted on the generator, okay? When you go and do this application over in a whole house, if you want to use that portable generator to run things on your house and plug directly into the house, I mean plug directly into the house, so it's going to go through the panel and you have an interlock, that type of thing, then you want to make sure that it's an unbonded generator. Now, I've done a video on this. I think it's still available over on YouTube. I don't think it's been moved 100% over to Fast Track's tube yet, but now that we have the quicker speeds, things are moving more rapidly. I think Jeff has slated for another 10 videos to be moved this week. At some point, he may have already done it. I don't know. Jeff's not here today or not in today. So, but at the end of the day, we do have educational videos up there on that, but you need to be well versed in that. But 99.9% residential applications, even if you're doing an automatic transfer of everything, they are not going to be switching the neutral. So it is not separately derived. So you do not want to have a system bonding jumper installed out at the generator that connects the neutral to the frame, okay? And as an electrician, I was involved in a case, you've heard me talk about it years ago, with the death of a small child due to an improperly installed generator, but it really was due to the manufacturer sending the wrong components, but the electrician didn't double check it. And there's always got to be those levels of double checking things, right? So in their scenario, it was the wrong transfer switch was sent, but the electrician didn't catch it in that, but they didn't get sued. It was the manufacturer that got. But at the end of the day, it all settled anyway, but be very careful. So as an electrician, always double check. Don't take things for granted, right? Always double check before you energize, especially when you're dealing with a customer, right? Because they're the ones that are going to get you in trouble, right? Now, portable generators, if you're just using it on a job site, bonded generator. If you're going to be using it, again, on the house, unbonded generator. What are the different types of standby power systems are available? Well, home centers like Lowe's, Home Depots, all those big box stores. My generator, I actually got my generator from Sam's Club, believe it or not. My friend up in Northern Virginia got his, I believe, from Costco. I think that's where he got it. But you can get them at many supply houses. You can order them direct a lot of times. But again, I never had a need for a whole house because I don't really... I have a soft start on my AC unit. I can run AC, and when the winter comes, I got heat. I got logs that I can turn on. So I don't worry. I just wanted to be able to run just about everything in my house, but I didn't need to do it automatic because I like to transfer. I'm an electrician. I like to play with that stuff. I like to do my load balancing, and I just didn't need a whole house. But that doesn't mean that I'm not installing it for a client who is a 70, 80, 50, 60, whatever, and they don't know anything about this stuff, and they want the hassle-free, they don't want to get involved in that stuff. I get it. To each his own, okay? But in the day, I made quite a bit of money, contractor, putting in inlets and then mapping the power and then putting the little green dots on the breakers that they could turn on. that type of thing, and then giving them an instruction sheet that they can follow step by step. And that was cheaper. I think I put my inlet set in for mine, everything, even the generator, everything, all in. I think it was just under $2,000. So, compare that to putting in a whole house, the ease of having it run everything. Well, my generator, I have a 12,500 start and a 9,500 run. And my house is so energy efficient, it runs everything, except for the 10K strip heat, which, I wouldn't even turn that on if I knew that the temperature was going to be down below 30 degrees, because I don't want the auxiliary heat coming on, and that would bog my generator down. And in my thermostat has a setting so that automatically locks it out when it gets to a certain temperature anyway. I don't want to alter that, so I just be very cautious of when, when I'm going to transfer. What's the temperature? What's the expected temperature? And you know what? Believe it or not, your weather apps are very accurate. So I just open the weather app and look and see what the expected temperature is, that type of thing. Very easy to do. But anyway, that's just me. Where was I at? I'm sorry. Feel free to chime in, folks. Anything you want to ask or talk about, this is what we're here for. All right, so the simplest and most economical portable generator consists of gasoline-driven generator set that is manually started. Now, my generator has a remote setup, so I got a little remote to start it. Got to just keep the battery charged, right? And usually running it once a month keeps it from getting clogged up, keeps everything lubed, it keeps everything running. I just have a notice that comes from my Alexa device. Will send me a notice and say time to run generator for 10 minutes. So I just go and push the button and let it run for 10 minutes. I won't even transfer. I just let it run for 10 minutes. It charges up the battery, keeps it charged, and they pull very little. Okay, these batteries now, unless it's in the middle of the winter where they discharge a little bit quicker. Other than that, they hold a charge perfectly fine. It's just a habit. I like to just cycle it, once a month. And the reason for that is just to keep everything so that I know it's running. Same thing with my excavator. If I'm not going to use it, I'm still going to run that thing for 20 minutes once a month or something, so that nothing gets gooked up. And you know what I'm saying? It's just a process that we go through when we have our toys. Okay. My generator is actually gas and propane. You can do either or. Okay. When you store it, I know because I never store my generator. My generator is there to run whenever I need it. So it's a portable generator that is unbonded, that is mounted on a rack system. When I'll show you that one day, I'll show y'all mine. Mounted on a rack system that's off the ground, and it's only used for it. And so I leave gas in it all the time. I do put some stabilizer in with it. Ain't gonna hurt anything, but I need it to always be ready. That type of thing. So be honest with you, I never drained my generators because I never knew when I was going to need it. So storing it was kind of like I never knew when I needed my generator. So when I put my generator, I'd put a little bit of like Stabloy or something in it, or whatever the additives are for the gas. That's what I do, and I never drained them. Okay. Brandon says, yes, it is required to have an interlock. Yes, portable generator and a whole house application. Yep. Is it required? So you have to have transfer. So the code requires 702 that we actually have a transfer. Now, interlock is considered transfer. People have been arguing this forever. The key here is that nothing says it has to be automatic or manual. Manual's fine, but the transfer, it has to be a way that you can't have the main on and the breaker for the generator. So there's an interlock so that you can't accidentally turn the two on. So that's the requirement for the transfer device. And that's what that is. But of course, I don't do, if you have an interlock, is a 100% probability, right? If you have an interlock that you're not doing a whole house application. I'm not saying that for everybody, but it's a high probability that the people that install the interlock kits, and be careful with those interlock kits, they don't all mount the right way, okay? They come with instructions, especially now you can get them for $20 off of Amazon. Be careful, all right? Just be careful with these interlock kits and make sure you double check before you drill that cover. I'm just saying, Learn from experience. But yeah, I mean, typically you're just going to be doing selective loads in the house, typically when you do an interlock system like that, typically, right? Because if you were going to do the whole house like that, then you'd probably go on and just put in a whole transfer switch or something like that. I guess I could be wrong, but it doesn't matter. You still need that interlock so that one breaker can't be on with the other, and all the labels are accordingly, that type of thing. Right? We certainly don't want to backfeed the system and that type of thing. And on my generator, I actually have an alarm called a power back alarm that when I switch it to generator, I turn the alarm on, and it has a coil that wraps around like a CT that wraps around one of the power lines coming in, so that it will go off when power comes back on. It'll send out this really loud alarm. I mean, it's obnoxiously loud. And no matter where I'm at in the house, I could hear that, right? And then I go down and then I would turn that off, and then I would turn off the generator and turn off all the loads, and then turn the main back on, and then slowly turn all of my loads back on. That's how I would do it. Leo says the little bumps for screws that are meant to be pre-drilled do not line up with where they're placed on the panel. Yeah, be careful. Those little things that you put, the little plate you put on there, and you follow the drawings on these things, and you do it just like it shows it, lined up with the opening for the breaker, that type of thing. Folks, be careful. Do that, mark your holes, and then set your part that moves, set that up there to make sure it lines up with those holes. I recommend using a dry erase marker so you can remove it. I use dry erase pens a lot, especially when I'm marking on things like panel covers, because I can wipe it off. But I put it up there, and you find out that it needs to shift a little to the left because it won't clear the breaker. I have so many comments on people doing that. I mean, you could, take the holes if you mess up, and you could, kind of like ream them out and move it to the side so it has a little bit of movement on it. It's not going to hurt anything. But again, all these little interlocks that you buy online, just be careful because some of the instructions are weak, okay? They are not very good. And you might think it's simple, but once you start drilling holes in your metal, that ship is already out of port, and you just have to be really careful. So definitely, make sure, okay? Michael says, what do you think about GenLink device? We install them, and customers seem to like this technology. The utility in your area must approve. Are you talking about the ones that go on the meter? That type of thing? Let's see. Jonathan, you have good luck with the 75. Yeah, mine, I think when I put mine on, it was $20. But the instructions were not accurate. Okay? And I had to alter mine. I had to fix mine because the instructions were not accurate. Buying a better brand, nice brands like the ones from interlock.com, that's all they do, or then you're probably more reliable. Buying something from Amazon, it looks nice, looks solid, but you got to know what you're doing, because if you follow their instruction sheet they give you, and you mount that back plate and mark your pre-drill holes, it's not going to fit. You're going to have to be a little more to the left. Since it's top right mount breaker, you got to be a little more to the left. So otherwise it won't clear that 50 amp breaker. You know what I'm saying? That type of thing. Yeah. I don't have a problem with them, again, because it's optional. It's not going to be allowed for anything like legally required or emergency, but optional as long as your utility's okay with it and they make those meters and it's their meter, right? That type of thing. Then I wouldn't have any problem with using that type of thing. And I haven't looked enough into them, but if the utility's okay with it, that's fine with it. Now, the only problem is that I don't know enough about limiting, because it seems to me that coming in separate to a breaker allows me to have the interlock. So I'm not 100% sure with how those meter installed ones work. Because if that means you have to have a generator that can run everything, or you got to, even though it comes in on the main and it switches out there automatically at the meter, you still could have a situation maybe where you plug the generator into it. and then it switches over and you've got too many loads on and it bogs down your generator. So I don't know enough about those that because it just seems to me if you're just plugging the generator right into the meter, then when the power is detected it's out, then what's going to happen is it's going to feed the entire panel. And if you have all the breakers on, okay, that type of thing. So my problem with that one, Michael, would be it's not going to work unless you size your generator to be a cord and plug. And usually, since those are cord and plug, usually you're limited in size, like 50 amps. I don't know what the inlet is on that meter, but if that's the case, that's a problem. Because if it's a 200 amp panel and you put this meter on there, and I don't know enough about them, but if you can do cord and plug into the inlet into the meter, then it seems to me that you'd have to size your generator to do the whole house because everything's beyond. So it just seems like I'd rather have the inlet and have the breaker that I can interlock and I can manually turn things on. So I don't know how that GenLink works. If it just loses power and it just turns on everything for the whole house, then what is the size maximum of that inlet? Because I've never seen generators that would be cord and plug higher than 50 amps for a residential, that type of application. I've never seen a receptacle outlet that would have done a whole house through that meter. You know what I'm saying? So I don't know enough about how it works, but if it's going to switch in the meter, because that's what's smart, it's still going to feed the power in through the service conductors down. And if everything is still on, if your generator is not large enough, because it's seeing everything, right? Yeah, see, that's the problem, Michael. Unless I'm missing something. Let's talk about this for a second, because I might be missing something with these. So if it's a meter and all it really does is detect whether the loss of utility, I plug a 50 amp generator in there. There's no interlock. So if it switches and it feeds the main breaker, just like it would through the meter, now I still have all of my loads on in the house, right? So I'm assuming it obviously it's not going to start the generator because you'd have to manually start it. So then I guess even though it's got power coming in, I mean, it's sitting there waiting. I guess that's when you can go in and then turn off all your breakers. Then you turn your generator on and then you set everything. That's probably must be how that works. It just seems like a pain in the ass. I just soon put the inlet in. You know what I'm saying? But seems crazy, but I get it. Now, there's no way that 50 amps can do a whole house, especially if you got an air handler, if you got heat strips. I guess it depends on where you're at in the country and the size of the house. But this just seems that it's still going to, it's basically what it's saying is it doesn't need an interlock because that's done at the meter. So even though, and no power is going to flow until the generator comes on probably. So if the power goes off, right, then you got to go down to the panel, right? Turn off everything. Now, Dan, I'm assuming that it keeps from backfeeding because of the technology that's built into the plug-in meter, okay, where the plug is. I'm assuming all that technology is in there. It has sensing. It can sense when utility's on and that type of thing. You get what I'm saying? But, and it must also sense that the generator's still running. Okay, when the power does come back on, the generator's still running. It must send something. I don't know how it works. I might look into it, but I like an inlet better personally. Okay, so I don't know. It's a good discussion, but I don't know enough about how those things work to be educated enough on them. But obviously it's going to block the power, that type of thing, and it's going to sense the generator current. So there's no way that the two can be on at the same time, right? That scenario. Now, what could, and it all gets done through the assembly, right? It has its own interlock built into it, okay? Tesla backup power, that is a power source, energy storage system. I think that it's, I'm again, y'all know I'm not a big battery fan. I'm not a big, now, if you have like a solar system, PV system, then yes, I don't think anybody should invest in a PV system unless they have battery backup of some type. Otherwise, you just think you're being green, that type of thing. So, but I'm okay with the backup generator, the backup banks as long as it's for a purpose, not just for backup for my house. I would not invest in one of those. Those things are 20 grand just for, no, hell no. I'm putting a generator in. You know what I'm saying? I'm not going to use a Tesla wall for that. But Tesla might be good if we're doing something like already doing a PV and you're storing every energy and things like that. Then that may be a viable thing, but they're expensive. So, all right. Anyway, so typically gas driven, or maybe you have one that is propane, or maybe even one that's tri-rated, natural gas, whatever. Typically runs 4 to 8 hours. Most of the power outages that I have are usually 2 hours or less, that type of thing. So I always keep spare cans of gas if I know a storm is coming, that type of thing. But usually just random power outages that you may have depending on your, where you're at. They don't last very long, okay? And that type of scenario. So the extension cord is run to critical loads. Now, again, this is extension cord. If sometimes people will use little portable generators and just run an extension cord in. I mean, maybe you have a job site generator that you pull out of the truck when you lose power. The wife's like, oh my God, the refrigerator. Fine. You can use a bonded generator for that because you're using a generator that's portable and you're running extension cords from it in for temporary power. Perfectly fine. Not what we're talking about, connecting it to a dwelling. This is just running extension cord loads. And I did that years ago. I had a little small job site generator. I can't remember where we were living at the time. We lose power. I had an extension cord that I would run from it in, and it would hit a four-way, and then we would do the refrigerator and all that. It was years ago. That was my early electrician. I wasn't going to put a whole house in because I think I might have been renting at the time when I was really young, that type of thing. But that's what I did. I used a little portable generator that I use on the job site for that. Generally, generator receptacles on portable generators sets are required to be GFCI protected. Absolutely. They're going to have built-in test GFCI, okay? All that kind of stuff. So this is an example where you might run into a situation where you need to have it just to keep your sump pump. Maybe it's during a storm or something like that, and that type of thing. So in this scenario right here, all 125 volts through 250 volts, single phase, 15, 20, 30 ampere receptacles that are part of a 15 kW or smaller portable generator, which is typically what this is going to be. Most of your portable ones are going to be smaller than 15. I started to buy a 15, by the way, but I didn't. I ended up with a 1250 or smaller. Used on a temporary basis are required to have listed GFCI protection. So that's 590. That's 590, by the way, if you can see that. 590 is for temporary applications. So I'm installing it. I'm using it for a temporary application. In this case, I'm running a sump pump, that type of thing. Okay. The next step is involved is permanent wiring and cord and plug connected wiring. In the event of a power outage, manual start the generator. I have a remote start on mine, but not everybody does. Flip the transfer switch from the normal to standby power and then plug in the power patch cord. Okay. Now, when we say transfer switching device, again, we're not talking about it has to be an automatic. It can be manual. And this is where we get into that situation where the interlock is a transfer switching device. As crude as it is a transfer switching device that allows me to make sure that I'm not going to have any involvement with, and this is if you're going to be hooking it into the permanent wiring system of a building. I want to be able to turn the power off, move up the little device, and then turn on the generator. I have, like I said, alarms on mine. I turn the alarm on when the power comes back on. I get this screeching siren. I go up, and then I turn off the generator down, turn all my loads off, turn the main back on, and then turn my loads one at a time. That type of thing. Let's see. Understand the difference between bonded neutral generator and a floating neutral generator. Again, I'm going to be doing a video on this, and I kind of talked about this earlier. I know people all the time that will grab an older generator that may be a bonded generator and then plug it into their house. And whether it's GFCIs involved or not, it may work or may not, depending on the generator. And they're okay, although it does create a hazard. But maybe it's temporarily and they're okay with that hazard. What I don't want people to do, and what I've seen people do, is do something. I know a guy one time who had the generator, but he did a suicide cord, whereas he had two male ends on each end. and he would put the male end in the generator, and then the other end he would plug it into the dryer and that type of thing. Absolutely not. And you know why? One, the code won't allow you to do that. Secondly, it means that when the generator's running, the end prongs are energized. Okay, not good. Right? We want the female side to be energized. So at any rate, it was called a suicide cord. That is a freaking no-no. And that's one of those things that I wouldn't even do that if nobody's watching, because it's just my luck. My wife would mess with it or do something like that. Okay. Do you need GFCI breakers for a generator? Yes, you do. If you got the 20, 15, and 20 amp mounted on the generator, you do. And some generators will have it even on the 50 amp, but it's rare. But some of them will. Okay, so that type of thing. So, all right. So let's kind of look real quick. Let me go. Let's go look this real quick. This is a good. It's an illustration graphic. Okay. All right. Let's kind of look at this, and we'll talk about it. Okay. So here's utility power coming in. Here is this is the main breaker, kind of crude. I'll zoom in a little bit so we can analyze this. So this is one way of doing it. Okay. This is one way of doing it. So here you got utility coming in. Here's your main panel, yada, yada, yada. Here's your main bonding jumper. Here's your grounding electrode system. This is your main panel. All right. So now this breaker is feeding a transfer panel. Then there's many different manufacturers make the smaller ones with very limited loads on it. And that's all you're trying to do is limited loads. No different than you're doing an interlock here. You're still going to be limited to the loads that the generator can handle, right? Because it's going to bog your generator down if you pull too much, okay? Good news in a dwelling, we got a lot of diversity. But you need to be mapping your system. And I'm going to do a video on that as well, because I think it's important to show how you just check it. It's basically just an amp probe, turn various loads on, and try to see what your expected load is going to be. That type of thing. Because at the end of the day, when it comes to the generator, it's not brain surgery. You know, it's a 50 amp receptacle on that generator, if that's what you're using. Your size of conductors, everything for 50 amps. You do all of that and you size everything accordingly. There's really no load calculation in sizing that. Where the calculation, where the process comes in is trying to identify which loads in the panel are going to be okay. For me, I'm going to be honest with you, my receptacles pull nothing. The lights are hardly nothing. So what I'm looking for is I want to see what cumulatively, I want to see what my sump pump pulls. I want to see what my well pump pulls. I want to see what my air conditioning unit pulls, which is nothing, by the way. 5 amps for air conditioning. It's the heat strip that gets you. So at the end of the day, I'm trying to see collectively what loads I'm safe to turn on, right? That type of scenario. That's what I'm trying to do, okay? In my calculation, or not my calculation, but my analysis of what loads I can put on, okay? That I'm not going to overload that 50 amp breaker. Thomas says, I've seen Tesla power walls and batteries without PV where variable rates apply. Okay, it's a lot of money. A lot of money in those Tesla power walls. They're expensive. Charging the batteries with utility at a lower rate and using the batteries to load shave during higher rates. It seems expensive to me. Is the return on investment worth it over time? Is it that big of a savings over time that it pays for those installs of those Tesla Powerwalls? I don't know. I just don't know if the numbers add up. You know what I'm saying? Okay. All right. So anyway, let's look at this one here. Now this one's interesting because now you see this panel here. This is your separately installed. We're not talking interlock kit now. This is where you're feeding a separate. You can buy those little transfer switch with an automatic transfer, and you see that down here it's also switching the neutral, right? Switching the neutral, right? Right there. So it's isolated, okay? All right, so that's the scenario. This is right here is a 3-pole transfer switch. Let me see if I can, hold on for a second, folks. Let me see if I can get more in the screen there. So this is a 3-pole transfer switch, okay? Switching all 3 poles, okay? The B is the feeder with an equipment ground. So you got your feeder coming in and it's not showing it, but you got an equipment ground. So it's a 4-wire setup, right? And here you're isolating neutral again, okay? Just like you normally would for, it's like a normal remote distribution panel. The only difference here, like I said, is this setup And you can buy, again, those little things. I can't remember the name of the company that makes them. A very prominent name that's what they do. Reliance, maybe, or something, that they make these little 6-circuit panels with a inlet in it, and it actually will switch the neutral. It switches everything. So if that's the case, right, then here you're looking like, okay, it's a warning signs required at inlet to indicate the connection is for a bonded neutral system, right? Now, why is that? That's when you can use a bonded generator. Why? Because it's switching the neutral, right? And that's perfectly okay because you're switching the neutral. Whereas your labeling would have to be different, right, if this was an unbonded system, right? Because then this would not be switched. Now, this would not typically be the setup that we're talking about. This inlet here would actually come from a breaker in the main panel, come out and hit the inlet, and you would put an interlock in here so that this can't be on for utility while this is being back fed into it, okay? So that's how that scenario would work, okay? You never said they thought they were smart. But the question is, did they ever save any money on it, or did they just doing it to feel like they're giving back to the world or whatnot? You know, it's a funny thing about energy and saving the world and emissions. And I hear the world is getting shaken up right now. My brother told me that the world is being shaken up by the fact that they're changing the Freon or coolant again for HVAC systems. They're going to like a 54 or some other model. They're going away from the 410A because of the ozone. They went away from the 22. And so now they're moving to some weird proprietary, okay? And it's supposed to be more flammable, but it has less stuff that it emits into the atmosphere. And I'm sitting there going, it's driving me absolutely crazy because we worry so much about that shit off gases that, yeah, R450, yeah, it's crazy, right? And even Train is using something different than somebody else may be using. Yeah, R32. You see, yeah, it's what happened to just 410? And they're like, well, because of the gases. First of all, I don't know how much of that's leaking in the atmosphere. Secondly, because most of the people I deal with, HVAC guys, recapture that stuff. You know what I'm saying? And you know what? We could actually do all of this with propane and make life easy, but nobody wants to do that because propane's flammable. But this new 454 and 32 are flammable, so propane is used all the time in RV AC systems, and it works just right. But that would be too easy, right? That life would be too simple, right? If we did that, right? We got to be complicated. The world's full of proprietary stuff that we have to buy and pay more for. You get what I'm saying? But we have air conditioning systems that use propane as part of the coolant system. So don't get me started on that. But anyway, he was talking about that, right? Yeah, it's all about the money. That is true. All about the money, okay? It's the same as mine's a 410A. It's not as environmentally friendly, but you know what? Who gives? I don't know. I'm going to get in trouble for saying this. And I know I'm going to offend some people out there. Are you ready? I don't give a shit about the off gases from a 410 in the environment. One, because they're recapturing it. Two, there's more problems with the planes that are flying and all the vehicles anyway. So this is small beans, but it's big money for those manufacturers. Okay. And you remember, all of the stuff that we do in the US only account for about 2% of the world's pollution. India's not doing anything. China don't give a darn. They're not doing anything. Why is it that we are so concerned about saving the environment when everybody else doesn't? And what we do is not going to offset what they do. Go look it up. Don't believe me. But we try to do so much to be good stewards to the world, right? But China, India, all these other countries could care less about it, and they contribute way more to the global warming and the environment and the ozone layer and depleting it than we do in the US. You know what I'm saying? We are too freaking woke. There, I've said it. All right, I've said it. Probably lost some viewers. I don't give a shit. All right, so anyway, this is what you would set up, you would see. So you could use a normal bonded generator that you would use on a job site. You could use that as long as you're switching the neutral. Okay. There you go. Right there. All right. But if you are not switching the neutral, then it is not a separately derived system. Then you want a unbonded generator. Okay. Okay. Enough of that. Get me back to the lesson here. Okay. Now, all right, so that's that one. So here, let me switch to the next picture. Boom. So here's the next one. Now notice something that's different here. Now this shows it out in a panel, but this could be exactly very similar to how it's done inside of your panel with an interlock. Same kind of concept. So we'll scroll in on this one. So notice that the neutral is solid, and this is probably 99.9999999% of all residential generators that you get. You're not going to be switching the neutral. Okay, so here, this just happens to be shown in a separate unit, but I just want to convey to you that this could be an example of the interlock. So instead of it being in a separate panel, all these breakers are the breakers that are in your panel. All of this is done in the panel. And again, it's not switching the neutral because all of this wire that's going from here to the to the inlet is all on the same bus inside of this main breaker. Okay, so it's all tied together, okay, at the service, right? This is just shown it broken out for simplicity's sake. So in this case, if you're not switching the neutral, so it's a solid neutral, which again is the majority of the generator applications are not switching the neutral. So here you see it's just a 2-pole transfer switch, just switching the two hots, right? And then you'll notice that this is still isolated neutral. This is still your equipment ground. You still got 4 conductors running to it. Same as if you just did an inlet and you ran it over here to the panel, still 4 conductors, your neutral, equipment ground, 2 hots, right? It's just being shown here instead of just running straight to here where you'd have an interlock, okay? I got to keep reiterating that in case somebody comes in later. All right, now, B right here is fed with the equipment ground and conductor. Absolutely. Always got to have an equipment ground and conductor, okay? Now, notice the warning. It says warning signs requiring an inlet to indicate the connection is for a generator having a floating neutral because it is not separately derived. Why? Because it's connected to a system and there isn't a total separation. Remember I used that transformer example, primary to secondary? Well, if it's a solid neutral, you don't have a total separation from one side of the system to the other side of the system. So by definition, it can't be separately derived. If it's not separately derived, folks, you treat it just like you would a range, just like you would a dryer, just like you do a remote distribution panel. The frame cannot be connected to the neutral conductor. That's why we want a floating, okay, generator if you're going to use it on a system like this where you put an interlock in, okay? And this is your generator right here, okay? And that's the kinds. Now, I'm going to do a video, like I said, of the proper way to take a bonded generator and make it an unbonded generator, but I'm going to show you that it's in the manufacturer's instructions. So I'm not just wing-dinging it, getting some little cheap generator somewhere and trying to figure out how to remove the connection between the frame and the neutral, okay? I'm not going to tell you how to do that. You can figure it out, contact the manufacturer, but in the one that we're going to show you in an upcoming video, it's designed to be used with houses, or dwellings, so it has a procedure on how to move it. And it's basically just take one screw loose, move the wire over, put it back in, and done. Very simple. And it's done through the armature, okay? So we're going to show that in an upcoming video. Say, top of the line standby power served by a permanent installed generator. Instead of running extension cords from the portable generator inside, around and located outside the house, branch circuits are placed in the panel board that transfer to the generator manually, okay? Unless you have an automatic transfer and it does the whole thing. Just remember, that is not an emergency standby. That is just optional standby. You choose to make life simple. Turn everything on. That's where a majority of the generator installers make a living because people don't know this stuff. They don't want to mess with it. They just want to have endless power. Now, me as an electrician, you as an electrician, you determine what you want. If you're already a dealer for generators, you're probably going to put in a whole house. But for me, I did not justify the need for a whole house because of what my expectations are and historically the power reliability of my jurisdiction. Okay, so I was like, no, I don't need it. Okay. Now, Wiring diagrams for a typical standby generator. Actual wiring consists of 2 ungrounded conductors and 1 grounded neutral conductor. Equipment grounding of all of the components is accomplished through the metal raceways that interconnect the components. So we're just setting the stage for the illustration, right? And I don't know where that illustration is. It talks about a wiring diagram, and I don't see the diagram. So hold on for a second. I'm trying to see if there is a diagram. Let's see here. Hold on for a second. Let me see if I can find if there is a diagram. Let's see, wire diagram. Yes. Okay, so I'm going to send you over because there is a diagram. I knew there was. Okay, so let's share this instead. Okay, so this is, this is for a natural gas driven generator. Okay, all right. Well, there you go. Here's your generator coming in, natural gas powered. There you go, coming in, breaker on the generator. Coming in, there you go, coming in. This is a double pole, double throw right here, okay? So here's where it's switching right here. Only showing the power, by the way. Okay, only showing the power leads here, not showing anything else typically. And so if it is main power coming in, there's the breaker supplying this. This happens to be transfer switch, okay? And it transfers it here. Then it goes over here to it says critical loads, but at the end of the day, it depends. If this is for residential, then they're not really, there may be critical loads to you, but they're not in a scheme of the world, they're not critical loads. And here you see, once you get over here, you've got the certain breakers that you can turn on, and that's how you typically would do that generator. Now, let's see here. So let's follow the logic. Okay, so this is if somebody installs a separate panel. This is not for like what we do where they interlock. So this is a transfer switch, double pole, double throw, and here's your load. And this is a panel that it's supplying. When it's in this position, power's coming in, going through the breaker as normal, going out, boom, 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 powering everything under normal, right? Generator comes on, power's lost, everything comes through here, sitting here, but now the generator switches on. Power comes up, goes over this leg, comes over, and now powers everything here. Okay, whether this is manual or whether or not it's automatic, same concept applies. Okay, same concept's going to apply. All right, I was going to see real quick if we had any other images while I was looking. No, I don't see. Okay, yeah, I don't see any more of that type of stuff. Okay, let's get back to the lesson. All right, so that's a diagram. Transfer equipment. What does transfer equipment do? We all know what transfer equipment, whether it's an interlock or whether or not it's an automatic transfer or manual transfer. Basically, it shifts power from the normal to the standby. In this case, optional standby. Isolates the utility from the standby source. No feedback from the generator to the utility system, vice versa. Typically for residential applications, it's going to have a rating anywhere from 40 to 200 amps, depending on the load you're trying to supply. Okay. This is obviously not doing a whole house type of scenario. Okay. Unless it was the 200 amps and you have a 200 amp, or you could have a 100 amp transfer switch if you have a 100 amp. But if it's a 200 amp panel and you're doing 100 amp, you're transferring those specific loads that you set, that your dealer will set up in that panel. That's not considered a whole house because it's not doing everything. It's only what's been set up in that panel that 100 amp transfer, if it's automatic, can handle. It's probably not going to do everything. Well, if that's the case, then like I said, I just as soon have a manual transfer and do it myself anyway and select my own load. But again, just so you know. If you got any questions, please feel free to post them. Non-separately derived systems. Okay, properly grounded through the grounding electrode system of the premise wiring. Okay, so non-separately derived. We are not driving ground rods. We're not doing any of that kind of stuff. It's using the premise system. It's using the neutral that's not being switched. All those type of things. It's using the premises and stuff. So now sometimes you'll see a manufacturer that'll say in their literature, drive a ground rod. That's fine. Drive a ground rod. Connect it to the frame, because remember, if it's not separately derived, then the frame is not connected to the neutral. Then who cares? The manufacturer wants me to drive a rod and connect it to the frame and they give me a lug for it. Who cares? do it. That's what the manufacturer wants, right? And the concept is lightning dissipation from that frame to the earth, that type of thing. Okay. Now, not required. Totally a supplemental type of electrode that's the manufacturers are calling for. Doesn't have to meet the 25 ohms. Doesn't have to size the grounding electrode conductor for that. Does not have to be sized per 250/66. That is not required by code. That's something the manufacturer wants. Go for it. That is a non-separately derived system. Again, remember, treat it like a range, an oven, a remote panel. Total separation. No neutral should not connect to the frame. So basically a floating or unbonded generator. Okay. Now, if it is a separately derived system where they are switching the neutral and you are installing that type of generator, okay, then the neutral is disconnected at the transfer switch. And if that's the case, if it is separately derived out at the generator and it is truly a separately derived system, then you have to establish a grounding electrode system for it. And you could use the grounding electrode system that's already there for the dwelling and just make a connection to it if you want. It's already there. The electrodes don't care, by the way. Okay, they don't differentiate between that surges, lightning, transients, and they don't care. So you could use that if you want. Okay. Let's see here. The rating of the transfer switch must be capable of safely handling the load to be served. Absolutely. You're certainly not going to put a 100 amp rated transfer switch on a 200 amp rated capacity setup. That makes no sense at all, and you wouldn't do that anyway. Must be capable of safely interrupting the available fault current that the generator or utility is capable of delivering. Yes, and make sure that typically when you look at these transfer switches, they're going to be kind of the same type of sizes that you would have when you're doing the utility, right? 22K, things like that. Typically going to be more than adequate, but you do need to know those type of things for it, okay? Let's see here. Disconnecting means required for a generator, 445.19. Oh, sorry, I wasn't on the lesson. 445.19, disconnect. It says that in that scenario, and we can go look at that in the code. Let me go on and switch to the code real quick. If I can get there. Okay, we're here. Let's go on and just go there real quick so you can see that. 445.19 or 18. Is it 819 or 18? Might be changed in the code. I think it's 445.18 in the 2023 edition. Okay, so right here. It says a generator other than, generators other than cord and plug connected portable shall have one or more disconnecting means. Of course, if it's cord and plug, it has a disconnecting means already, right? I mean, it's cord and plug connected. If you want to disconnect it, you just disconnect it, okay? So even if the generator is sitting there and it's feeding the house, it's not the same as a permanently installed one like a Generac or a Kohler. It's still considered portable. It's cord and plug connected. It's just being used as a supply to the house, and you're doing selective loads in most cases when you're using a portable generator, okay? Do they make generators? I've never seen a portable generator that is over 16 kW or 15 kW. I'm sure they make them. I've just never seen one. I had an opportunity to buy one, a 16 kW, so I guess they do make them. I had an opportunity to get one, but again, it was twice the cost, and it would have literally run everything, even my heat strips, and it would have been like a whole house. But I just didn't see the need based on my needs, and I couldn't justify the $1,000 or $1,200 more than the generator that I got. So again, everybody's got their own justification for what they do. Okay. All right. So cord and plug scenario, what we're talking about, not required. If it's a permanently mounted generator, then you have to have a disconnecting mean, and each disconnecting mean shall simultaneously open all associated ungrounded conductors. Each disconnecting mean shall be lockable open. And again, many times these generators have the disconnect built into the generator now. Okay, so that type of thing. And the means is permitted to be located within the generator behind a hinged covered door or enclosure panel. Okay, so where the disconnecting means is located, okay, within the generator, you have to have these labels that have to be applied. Now, the manufacturers will usually take care of this, especially if their disconnect is built into the generator itself to meet this requirement. Okay, just keep that in mind. Now, with that said, the one thing about the NEC is that everybody would like it to be nice and tidy and say, okay, I'm just going to go to 445 for generators. But you and I both know that you've got to go look at 702, right? Because it's optional standby. So we have rules there I got to meet. I got rules in 445, which is specific to the generator I got to meet. Whereas 702 is more to the application and all the other rules of how I'm using that generator or standby power source. So many things you have to follow. Now, even the conductors that are run outside, if it's a permanently installed generator, from the generator into the panel, that is outside, right? And whether it's feeders or branch circuits, depending on what it is, it has to meet the requirements of Article 225, right? This is why being an electrician is tough, because the code book is not written in a way that's for the everybody to be using. So like an instruction manual, do this, then do this, then do this. It's not how it's written, and I don't want it written that way because I need it to be where I go and get what I need. So, for example, how I approach it is I find out what I need for the generator, right? Makes sense. Then I go to 220 because it is outside feeder and branch circuit applications. I go and I look and say, okay, what do I got to do for 225? Okay, raceways, wiring methods, wet location. I got to do all that. Then I go, okay, it is a standby and it's an optional. So then I go look at 702, right? And I kind of follow these little pieces. And some people would like it to be just perfect. But it's not really, the NEC is not really designed to be that way. You've got to understand how it flows, okay? I might be working on signs up in 600, but I got to remember that I still got requirements for branch circuits down in 210 or feeders in 215. Or if they're outdoors, I got rules in 225. So you see how they work together? So this is for this is for this. You have to piecemeal it when it comes to the NEC, and that's the way it's designed, okay? All right, now, portable generators through the equipment grounded conductor in the power cord, yes. So again, even the portable cords are going to be 4-conductor. And I'm telling you, my generator cord is beefy as hell. I mean, it's nicely made, and it's 10 foot long, and it's designed a certain way. Hardwired generators, again, metallic wiring methods or other means acceptable in 250.118. So if it's a cord and plug type generator system and you're doing an inlet, then you have to have an equipment ground in there, obviously. If it's hardwired, you may get away with the raceway being the equipment ground, depending on what you're dealing with, okay? So keep that in mind, right? Nothing's going to say that you can't pull a wire in there, but you might be able to use the EMT or you might be able to use a rigid. However you're wiring it, you would be permitted to use that wiring method under 250.118 as your equipment ground. So then I'd only have to pull 3 conductors through it, the 2 hots and the neutral. Or if it's 3-phase, 3 hots and a neutral. You get what I'm saying? All right. You have options there. Conductor sizes from the standby generator. Conductors that run from a standby generator to the transfer switch and to the generator panel board that contains the branch circuit overcurrent devices, or this could be from your generator or your inlet in to your panel. If you're doing one of those type of inlet with an interlock, then that would be what it's run, okay? So conductors that run from the standby generator to the transfer switch and to the generator panel board that contains the branch circuit overcurrent devices shall be sized not less than 115% of the generator's nameplate current rating. So the manufacturers figure this in when they give you the portable ones. For example, when they give you the generator inlet, right? And it's 50 amps and you buy a generator cord, it's already pre-made, it's already set up, and again, from point A to point B. But where this is important is for those that are doing systems, standby. Remember, this is just standby generators in general, that any of this from the generator to the transfer switch and to the generator's panel, if it's a separate panel that's being supplied by that transfer switch, those conductors have to be sized at 115% of the generator's nameplate current rating. So you've got to know the nameplate to be able to look at that and determine the sizing. If you're buying it in cord and plug, you're already buying it and they've all figured in. But if you're doing this and you're running everything just in raceways and pulling single insulated conductors inside of it and you're sizing all that, Have to be very careful of that application. Okay. Generator size recommendations. Generators for home use are generally rated in watts. Mine is a 1250 start, so it can handle that start and won't bog it down. And then it's a 9,500 run. Okay. So it says you add up all the loads to be picked up by the generator. And again, when I'm doing mine, and I'm going to show this in a video, how I'm doing my loads, I'm going to pick up the loads that I'm going to be running, right, in it. And then I'm going to add another 20% capacity for future loads. Okay, not in the NEC, but it's just good ways to think about it. If you're trying to size what generator you need, try to come up with the loads that you want to power, and pick your generator, but then also add an additional 20% capacity, because you just never know what else you may run with this generator. Okay, so you don't want to buy it at their peak, at top, and then you don't have any headroom if you want to turn on another circuit, or you need to add another circuit. Have a great day, Tom. All right, now it says the type of transfer strip installed determines the minimum capacity requirement. Okay, so again, if I'm going to do an actual transfer switch and not an interlock, but a transfer switch, then the transfer switch rating, right, is going to be very important. Because if it's a 200 amp transfer switch, 200 amp loads. Let's see. Michael says, is there soft starts for portable generators? I don't know. I don't think so. I think the soft starts are not for the generator. It's for the things that they're going to be supplied by the generator. For example, I have a soft start on my air handler. I mean, my outside air conditioning unit. Not the indoor air handler, because the indoor handler has variable speed and it automatically has stuff, and most air handlers do. It's the outside unit, that big clunk, that big sudden inrush that causes a problem if you're going to have other loads on at the same time. So in order to counteract that, I'll give you an example. For mine, my outdoor unit is, I have a very energy efficient house, very thick walls, 12-inch walls in a basement, insulation. It stays cool all the time and keeps heating good. It's a 2-ton unit. It's 2,700 square foot. I downsized when I went from Texas to Virginia. It's just me and my wife. So, but I wanted a more easier layout for her and for me. And so it's 2,700 square foot. A 2-ton unit keeps that thing at 73 degrees nonstop. It just runs, it works brilliant. It's a Rude system. It works great. But the inrush on that unit was 59 amps. 59 amps. So if I have refrigerator going, a well pump happens to be going because I got to have water because I'm on a well. If I have all that running, and then this unit starts up even briefly at 59, it could bog down my system depending on what all I have on. Yes, I have a 1250 starting and then a 950 run, so it obviously could handle it. But at the end of the day, if that's 59 amps, and I got a bunch of other stuff running, you do the math, you do the Ohm's law, that's not good. 59 amps is not good to have that going on, right? So at the end of the day, I put the soft start on that, and it took my 59 amps for that piece of equipment, it took it all the way down to like 16 amps. That's massive. That means that it's not going to affect my generator if I have other loads running and that air conditioning unit starts up. Then it's basically going to, my generator is not even going to experience it. Plus the soft start's probably going to be easier on my compressor over time. It's going to make it last longer and that type of thing. And I have a soft start that's a learning soft start. It's called an easy start. It learns and it gets better over time. So again, that's what I have, that type of thing. So I don't know if that answers your question. Yeah, no shit. From inrush, 59 dropped it down to 16 on inrush. Is amazing. Soft starts, they definitely work. And it is a must. My brother's doing a house right now that has a generator, and the generator is gas, things that are in their gas. The generator can run everything except it would not run. And they have 9 tons worth of air conditioning in there, 9 tons total units. Their inrush on one of their units was 109 amps, just on one of them. So that system would not even be conceivable. Even if you calculate everything out, It would not be conceivable without soft starts on those outdoor units. It just would not be conceivable to run that house, okay? Because it's a 400 amp service, when you calculate it out, because of the gas loads, they did 400 just because it was a really big house. But at the end of the day, I think as far as the generator setup and its automatic transfer on 100 amps worth of loads, it basically would have run everything that he wanted, except, and even the air conditioners during the summer, not the heat strips, but the air conditioners, right? But when they start up, they would have bogged down the generator, even that brief moment, and it could have caused problems. So he has to put soft starts on all of them. And again, it's for me, it was a $400 investment. That, yeah, I mean, what do we like? Me and you, we like to see things. So yeah, when I see that 59 amps and now I put an amp probe on it and see that the startup, that inrush is now only 16 and the unit runs smooth, none of that clunky, worth the money. It's some way in my mind, and I'm not an HVAC guy, somewhere in my mind I'm thinking that has got to be saving the life of that compressor, because that slamming on and off when it starts, now it's just smooth, that type of thing. Anyway, that's just me. I'm not an HVAC guy, so I don't know. All right, anyway, NEC addresses optional standby, what we have in original. In 702, we covered that. Permanently installed generators require a considerable amount of electrical work, gas piping, all those type of things, permitting, finding out local ordinances, what's the sounds, how close you are if you're in a subdivision, bunch of paperwork that you have to do with the jurisdiction. Less paperwork when it comes to an inlet. All they really want is the money. There's very little to inspect, that type of thing. I appreciate all of you. Thanks for joining us today. Tomorrow, Friday, Beatbox Friday, we'll have another topic, that type of thing. So I appreciate all of you. See, look at that. Bad. He appreciates the longer streams. Guys, I appreciate all of you. Okay. So keep lying. Yeah. But you know what? Haters are being haters. And I love what Jonathan always tells me, they hate you because they ain't you. But at the end of the day, I get a lot of hate mail from people saying I'm too long-winded. I talk too long. I like to hear myself talk and all this kind of stuff. I think that every educator runs into that. And all I can say to the haters that feel that way, don't watch me. I'm not twisting your damn arm to watch me. You know what? It's a simple, novel approach. People seem to be so eager to want to go and say some nasty comment when I'm like, dude, I'm not twisting your arm to watch. You don't want to watch? Go watch somebody else. But the reason they keep coming back is because they like it, but they just don't want to admit it. You know what I'm saying? All right, folks. Hey, we appreciate all of you. Till next time, stay safe. God bless. We'll catch you tomorrow on Coffee Hour, where we'll do another lesson, and we'll talk to you then. Take care.